with Sarwat Ahmed. Be sure to like the video and subscribe this. Today I will solve October-November 2023 paper 970121. Today we will solve this paper. Let's start. For question number 1, the elements phosphorus, sulfur and chlorine are in period 3 of the periodic table. Table 1.1 shows some properties of the elements phosphorus to chlorine. The first ionization energy of sulfur is not shown. Number of electrons in 3p subshells is 3. This is 3px, 3py and 3pz. So 1 electrons, unpaired electrons in phosphorus. So this is for oxygen, this is for phosphorus and this is for chlorine, and similarly 4 electrons, oxygen has 6 electrons in p shells. Sulfur, this is for sulfur, this is for sulfur. Oxygen, sulfur has 3 shells, so 3p has 4 electrons and 1 is paired and 2 is unpaired. Similarly, in chlorine 5 electrons are in 3p subshells, 2 paired and 1 unpaired. Total number of electrons, unpaired electron is 3. So these are the unpaired electrons. Look at here, this is unpaired 1 electron in 3px, 3py and 3pz. And in sulfur there are 1 paired, 2 unpaired, and in chlorine 2 paired and 1 unpaired. First ionization energy kilojoule per mole is for phosphorus is 1060, and sulfur is as general trend is ionization energy increases across a period, but sulfur has less ionization energy than phosphorus because phosphorus has 3 unpaired electrons while sulfur has 1 paired and 2 unpaired. So due to the pair spin pair repulsion, sulfur has gradually lower sulfur has lower ionization energy than phosphorus. Chlorine is general trend, according to the general trend chlorine is going to increase. So chlorine ionization energy is 1260 and sulfur is 1000. Complete table to show the number of electrons in 3p subshells and the total number of unpaired electrons in an atom of p sulfur and chlorine. So this is done, and construct an equation to represent the first ionization energy of phosphorus. First, you know that definition of first ionization energy is that the 1 mole of electron is removed from 1 mole of gaseous atom. This is 1 mole of gaseous atom, this is 1 mole of gaseous ion, and this is 1 mole of electron. So 1 mole of electron is removed from 1 mole of gaseous atom to form 1 mole of monopositive gaseous ion. 3 possible values for the first ionization energy of sulfur are given: 1000 kilojoule per mole, 1160 kilojoule per mole and 1320 kilojoule. As written above as in the table that 1160 to 1320, that is not possible. So sulfur has 1000 kilojoule per mole, low than sulfur but higher low than chlorine. So this is in between the phosphorus and chlorine, lower than phosphorus and lower than chlorine. Explain your choice by comparing your chosen values to those phosphorus and chlorine. Sulfur has least nuclear attraction to outer electrons than chlorine and phosphorus. Sulfur has less nuclear charge than chlorine but greater than phosphorus. So this point carrying 1 mark, this point carrying 2 marks, and this point carrying 1 mark, and this is carrying 2 marks. So, sulfur has least nuclear attraction to water electron than chlorine and phosphorus. Sulfur has less nuclear charge than chlorine but greater than P. But sulfur has 2 electrons in 3p orbitals, resulting spin-spin repulsion. So, less energy is required to remove the electrons from outer shell than phosphorus. So, next question is phosphide, sulfide and chloride have the same number of electrons. Give the full electronic configuration of phosphorus 3 minus. Phosphorus has 15 proton number, and because sulfur phosphorus 3 negative, so has 18. Proton is 18. Proton is same, but electron number is going to increase. Proton is 15, electron is 18. 1s2, 2s2, 2p6, 3s2, 3p6. So, this is electronic configuration of phosphide. State the trend in ionic radius shown phosphide, sulfide and chloride. Ionic radius decreases from phosphide to chloride because due to the increased attraction between nucleus and outer electrons, increased nuclear charge with same shielding. So, that is why it decreases atomic radius, ionic radius decreases from phosphide to chloride. A student does 3 tests on the separate sample of sodium chloride. Complete table 1.2 with observations the student makes in each test. Addition of few drops of bromine, so no change as bromine is less reactive than chlorine, so cannot displace chloride ion in from sodium chloride. Addition of few drops of concentrated sulfuric acid, no change, no visible reaction as sodium chloride is salt solution, aqueous salt solution. So, there is no change with addition of sodium chloride in concentrated sulfuric acid, the pH remains the same. So, no reaction. Addition of few drops of dilute nitric acid, when we add few drops of sodium chloride AgNO3 in, so precipitation reaction occur like this, AgCl becomes solid plus NaNO3. So, white precipitate of silver chloride can be seen. Question number D part, POCl phosphorus oxide trichloride shows similar chemical properties of to PCl5. POCl3 has a melting point of 1 degree centigrade and boiling point of 106 degree centigrade. POCl3 reacts vigorously with water, forming misty fumes and an acidic solution. Explain how information in D suggests the structure and bonding of POCl3 is simple covalent. Simple covalent molecule, you know that simple, so it is the simple molecule. So, simple molecule has low melting point and relatively low boiling point, suggests that POCl3 has weaker intermolecular forces, या van der Waals forces. Construct an ionic equation for the reaction of POCl3. So, PCl3 like PCl3 with water, it is hydrolysis reaction to form similar reaction shown by POCl3 when react with water, phosphoric acid and hydrochloric acid is formed. POCl3 contains double covalent bonds. So, this is the instruction between P and oxygen. So, double covalent bond between P and oxygen. Complete the dot and cross diagram to show the bonding in POCl3. Show outer shell electron only. So, with this atom, oxygen atom has double bond. So, 4 electrons are there and rest are single covalent bond with chlorine atom, because chlorines are deficient of 1 electron. So, need 1 electron to complete its octet. Next question is POCl3 forms when PCl3 reacts with oxygen. PCl3 plus oxygen to form POCl3. The table 1.3 gives some relevant data. Minus 289. Enthalpy change of formation of PCl3 is minus 289. Enthalpy change of formation of POCl3 is minus 592. And oxygen to oxygen atom, enthalpy change of atomization is 2 oxygen, that is plus 496. So calculate the bond energy P double bond O in POCl3 using the data in table. So this is enthalpy change of delta H so this is delta HF, and this is enthalpy change of formation of POCl3, delta HF of POCl3 from PCl3 and oxygen atom. So 289 is enthalpy change of formation of PCl3 delta HF, and plus 496 is the enthalpy change of POCl3. POCl3 is 496 plus 496. So to delta HF of POCl3, so this is plus 496. So one curve, one is drawn like this, and other is this is direct route, and this is indirect route. So delta HF is equal to delta HF, and this is delta HF of POCl3 or minus 2 bond of PO. So this is plus the 2 PO. We calculate this value 2 minus 592. This is equal to plus 551. So this is the 2 PO, and the 2 PO is equal to 1102 divided by 2. So calculate on calculator, but the cycle, you have to draw the cycle like this. This is POCl3, and this is barium hydroxide is a strong question number 2 is barium hydroxide is a strong base used in inorganic and organic reactions. Figure 2.1 shows a reaction scheme involving barium hydroxide. Barium oxide dissolve in water to form barium hydroxide, and barium hydroxide in reaction to form barium carbonate and water. When we add carbon dioxide over here, barium hydroxide absorb carbon dioxide to form barium carbonate and water. And barium hydroxide also react with ethanoic acid to form barium ethanoate. So this is barium ethanoate. State the variation in solubility of group 2 hydroxide. Uh, group 2 hydroxide soluble down the group, so solubility increases down the group. What is observed in reaction 1? In reaction 1, white solid disappears and alkaline solution is formed. Suggest reactant for period 2. Carbon dioxide, as I have told you earlier, that carbon dioxide alkaline solution is absorber of carbon dioxide. So whenever in any alkaline solution carbon dioxide is added, barium carbonate and water is formed. Identify compound A. So when barium hydroxide react, this is neutralization reaction, that whenever any alkaline solution react with carboxylic acid, respective salt is formed, like barium. In case of barium ethanoate is formed. Barium hydroxide is made by the reaction of barium with water. Write an equation for this reaction. Barium group 1 and group 2 metals below than magnesium all dissolve, like group 1 and below than magnesium, calcium, strontium, barium, lithium, sodium, potassium, rubidium, cesium, francium. All these metals are just like this reaction, they dissolve in water to form alkaline solution and hydrogen gas. So this is alkaline solution or effervescence of hydrogen gas. So all these metals of group 1 and 2 show the same reaction. The mineral berylcosite contains both barium carbonate and calcium carbonate. Both compound decompose on heating. State which compound decompose first when berylcosite is heated. Barium carbonate and barium is more reactive than calcium. So the more reactive the metal is, the most stable compound is formed. So that's why barium carbonate is more stable than the calcium carbonate. Down the group, stability of compound is going to increase, thermal stability of compound is increased. So require more heat to decompose barium carbonate than calcium carbonate. State which compound decomposes first. So calcium carbonate decomposes first, then barium carbonate, as calcium carbonate is less stable than barium carbonate, because stability increases down the group. Magnesium carbonate, calcium carbonate, strontium carbonate, and barium carbonate. So barium carbonate is most stable compound of group 2. So we can say that it increases down the group. Construct an equation for the complete thermal decomposition of barytocalcite. The formula of barytocalcite is this. So this is the decomposition of beryllocalcite. Barium oxides, two oxides are formed along with carbon dioxide. So whenever carbonate is there, carbon dioxide is definitely evolved on decomposition. When we heat this compound along with two oxides, barium oxide and calcium oxide, carbon dioxide is formed. Barium hydroxide is used to hydrolyze organic compounds. Figure 2.2 shows the reaction of B with barium hydroxide followed by acidification. Draw the structure of the organic products of the process when shown in figure 2.2. So this is the ester. This is the ester First, when barium hydroxide react with this compound, so this is hydrolysis reaction, and it is formed all RCO2 Ba plus methanol. So this is the compound formed, and then nitric acid. First, and nitric acid act on this compound hydrolysis and changes into COH, carboxylic acid. So the first organic product is methanol. This is the organic product 1, and second organic product is this, because this CN is hydrolyzed to form carboxylic acid. Nitrile is hydrolyzed to form nitric acid, and along with the barium nitrate. So barium nitrate is also formed in this reaction, because nitric acid react with this compound. First add barium hydroxide, then this compound changes into carboxylic acid, and this is again carboxylic acid plus barium nitrate. When this react, potassium chlorate is widely used as an oxidizing agent and to make oxygen. Define oxidizing agent: compound which oxidizes other substance but itself is reduced after gaining of electron. So KClO3 is decomposed when heated. Manganese 4 oxide catalyzes the exothermic decomposition reaction. Complete the table. KClO3 is decomposed like this: KCl plus oxygen. So this is the decomposition of KClO3. So this reaction is catalyzed by manganese 4 oxide exothermic decomposition reaction. Complete the table. A label diagram figure 3.1 on the decomposition of potassium chlorate. This is with catalyst, and this is activation energy of because catalyst lowers the activation energy, and this is without catalyst, and this is the activation energy of without catalyst. So it lowers the activation energy. When KClO3 is heated without a catalyst, KClO4 and KCl form. So KClO3 is heated with catalyst KClO4, and KClO4 and KCl form. So because KClO4 is a catalyst, so it is regenerated in this reaction and along with other product, that is KCl. So explain why this reaction is described as disproportionation reaction. As chlorine over here, KClO3, in KClO3 it is because chlorine is oxidized and reduced. In this KCl carrying -1 and KClO4 is equal to 0, potassium 1 plus X plus 4 minus 2 is equal to 0. So 1 plus X minus 8 is equal to 0, and X minus 7. So X is equal to 7. So KClO4 has plus 7 oxidation state, and this is KClO3, like look at KClO3 is equal to 0, because oxidation state of any compound is equal to 0. So K is 1 plus X plus 3 minus 2 is equal to 0. So 1 plus X minus 6 is equal to 0, X minus 6 minus 5, and X is equal to 5. So over here plus 5, So this is oxidized going to +7, and this is reduced when changes into -1. This is reduced, and in this case oxidized, as oxidation state is going to increase. So in this way chlorine is both oxidized and reduced, so that's why it is described as disproportionation reaction. Molten KClO3 reacts with glucose KClO3 plus 6 C6H12O6 to form 6CO2 and 6H2N plus 4 KCl. KClO3 melts at 630 Kelvin. At this temperature both carbon dioxide and water are gases. Use the ideal gas equation to calculate the volume in meter cube of 1 mole of gas at 630 Kelvin. This is temperature. This is 1 mole of gas. Volume, we have to find out volume, and this is pressure. We have equation PV is equal to nRT. We have to find out volume, so modify this equation like this: V is equal to nRT over P. V is equal to 1 mole, 8.31 is the gas constant, and this is temperature in Kelvin. This is temperature, and this is pressure. So by calculating this value we get 0.0524 meter cube answer. So volume of 1 mole of gas occupies 0.0524 meter cube. So this is 3 significant figures. So answer should be in 3 significant figures. 5 gram of C6H12O6 reacts completely with molten KClO3. Use your answer to D1 to calculate the total volume of gas released at 630 Kelvin and 1 into 10 raised to 5 Pascal in this reaction. If you are unable to answer D1, use 0.046 meter cube in this question. This is not the correct answer. Go to D1. So 5 gram of glucose, first find out mole of glucose, 5 over 180. 180 is the MR of glucose, so we get 0.0278. So by using mole ratio 1:12, so in reaction this is the 1 ratio, because these are two gases, so 6 plus 6 is 12. So 12 is gas, 0.0278 ratio X. So the total volume is, the mole of gas is 0.336, and the volume of gas is mole into 0. We are using this volume because 1 mole of gas occupies 0.0524 meter cube. So the answer is 0.0175. Next question, E is the structure of glucose is shown in the figure. This is the skeletal structure of the glucose. Complete the table to identify the number of primary, secondary and tertiary alcohol groups present in the structure shown in figure 3.2. You know that this is the primary alcohol. This is primary alcohol because CH2 2 hydrogen attached with the carbon attached to hydrogen atom, which is directly attached to alcohol group. So this is primary alcohol. So this is secondary alcohol because one hydrogen is there. This is again secondary, or this is again secondary alcohol. This is again secondary. This is again secondary. So 1, 2, 3, 4 are secondary alcohol. So we don't have tertiary alcohol. So tertiary alcohol has CH3, CH3, CH3. So carbon has no hydrogen which is directly attached with alcohol. This is tertiary alcohol. Separate samples of aqueous glucose are treated with the reagents shown in the table 3.2. Complete table 3.2 with the observation for each reactions. Write no reaction if applicable. Acidified potassium manganate are warm and reagent. Because alcohol are there, so alcohols are oxidized in the presence of acidified potassium manganate on warming, so the color change is purple to colorless. Failing reagent and warm. Failing reagent is also an oxidizing agent which reduced this compound alcohol. This form ketone, this is changes into ketone, and this is carboxylic acid, this is aldehyde. So failing reagent and warm, so red precipitates in case of failing reagent. Alkaline iodine and warm, no reaction. Alkaline iodine and warm, this is no reaction because this is CH2OH, this is CH, so no CH because this reaction takes place when CH3 is directly attached with the carbon which is directly attached with OH, or CH3 by using C double bond O, or CH3 C double bond OH. So alkaline iodine react on such compounds. In which C double bond directly attached with CH3, this in this aldehyde CH3, C double bond directly attached with CH3, and in this case this CH is directly OH and directly attached with CH3. One CH3 should be there and it is directly attached with OH, the C carbon, and this carbon is also attached with O, so this shows the positive test with alkaline iodine, because in this compound we don't have such combination, so there is no reaction. There are many structural isomers of 6C6H12O6. Define structural isomers. Molecules with same molecular formula, molecules having same molecular formula with different structural formula, or compounds having same molecular formula but different structural formula is isomers. Compounds C and D are alkenes with the same molecular formula C5H10. Give the systematic name of D. So this is methyl, this is alkene, this is again methyl. So this is 1, 2, 3. 1, 2, 3. Now start from here. 1, 2, 3 and 4. 1, 2, 3 and 4. So this is 1, 2, 3 and 4. So on this way 2, 3, 4. 1, 2, 3 and 4. This is 1, 2, 3. So this is 3 methyl, 3-methyl but 1-ene. Explain why C and D not show geometrical isomers, because as double bonded carbon has no has same groups, like this has H and H, and this is CH. So this is the same group, and C and D do not show. This is also do not show the same, like this carbon H, and this is CH3, and this carbon H, and this is CH3. Like look at this CH3, this is CH3, and this is the same group of atom. So that's why C and D do not show geometrical isomers. Draw the structure of a molecule that is positional isomer of C and D. This is a positional isomer. Draw the structure of molecule that is positional isomer of C and D. So this is 1, 2, 1, 2, 3, 4. So this is a structural isomer of this carbon CH3, CH3. One, two, this is a compound like this. And this is like this. Draw the structure of the molecule that is a positional isomer of C and D. One, two, three, and 4. So this is the structure give the, and this is 1, 2 methyl but 1 ene. Give the structure formula of the compound formed when D reacts with hydrogen in the presence of catalyst. So double bond is going to removed. D react with, this is D, and when D react with CH3, CH3, CH, and CH3. So this is the structure formula when D reacts with hydrogen in the presence of platinum catalyst. C can form an additional polymer. Addition polymer, draw the structure of one repeat unit. So this is the one repeat unit like this. So first modify this structure, like we have C double bond, this is the polymer, and this should be monomer. C D, this is monomer. So this is the monomer and polymer like this. This is monomer and this is polymer. B part is the mass spectrum of C, shows mass over charge is 70. This peak has a relative intensity of 48.7. The relative intensity of the M+1 peak is 2.7. Show that this information is consistent with the molecular formula of C. So we have this is the MR of the compound, and we have this compound CnH2n. Spectrum C shows, this is the spectrum C, and it is alkene, and its molecular formula is 7, molecular mass is 17. So we have this mass, the formula is 100 over 1.1 n is equal to m, where n is the number of mole, number of carbon atom, or n is equal to 100 into m+1 over 1.1 into m. So 100 into 2.7, the number of carbon atom we get is 5. So in case of alkene, so number of carbon atom is n is equal to 5, and we derive formula CnH2n by using this formula C5H2 into 10. So this is C5H12. So we have number of carbon atom is 5. So in this way we can calculate the number of carbon atom, and prove that molecular formula of C is if MR is 70, then molecular formula of C is C5H10. C and D reacts with HBr. C reacts with HBr to form E, C and D. Complete the diagram with HBr, electrophilic addition. So this is the how to show the curly arrow. So this is hydrogen carrying partial positive, because when it come close to the double bond, this has high electron density, so due to which hydrogen carrying positive, partial positive, and bromine carrying partial negative charge. So bromine atom attract all electrons, bonded electrons, towards its center, because it is highly electronegative, and form bromide ion. So this is double bond is going to break and carbocation is formed. So in second step, bromide ion has excess pair of electrons, which is donated to this positive carbocation to form this compound. D reacts with HBr to produce F. D reacts with HBr to produce F, a chiral bromoalkane. Said this is D, this is D. So this structure is D, and when HBr react with this compound, it is form major product like Br attach over here, and by after breaking the double bond, HBr, this is carrying partial positive, this is carrying partial negative, and Br H tagged with this carbon atom, and this is going to attach with this bromine, highly electronegative, attached with the carbon with less number of hydrogen atom, because over here this is alkyl group and positive inductive effect is decreased. So that's why highly electronegative element ion attached over here. So that's why this is Br over here H, and this is CBrH, and this is CH2, sorry, this is CH2, this is CH2 and this carbon is attached with 4 different groups: hydrogen, bromine, CH2 and this whole group. So it form chiral carbon. Explain why the reaction of HBr with C and D produces different major products. Carbon has tertiary carbocation, C has tertiary carbocation and secondary carbocation. So D has only secondary carbocation and primary carbocation. C has tertiary and secondary carbocation. This is tertiary and this is secondary, while D has secondary carbocation, this is secondary and this is primary. Alkyl groups have positive inductive effect. More alkyl groups mean more inductive effect. In C, tertiary carbocation is more stable. In C, this compound is more stable because this is tertiary carbocation. When double bond is going to break, this will become tertiary carbocation and it has more inductive effect. So in C, tertiary carbocation is more stable due to more alkyl group. C can be used to form H. C C can be used to form H. C can be used to form H. So this is C compound can be used to form this compound. So one possible synthesis of H is shown in figure 4.5. 4.5 different position of C are used in the reaction 1 and 3. Some of the products are then combined to produce H. So combined to produce H. This is HBr, reaction HBr, and the reaction is this, like this, and reaction 3 G, and this is C double bond O. This side is changes into, this is CH3, this is C, and this is CH3, and over here double bond O, this compound is formed, and this is 2 carbon which is going to change, plus CH3 CO2H, and reaction 2 form this. This is nucleophilic substitution, and reaction 2, then J and G. This is J and this is G to form ester. J and G, this is ethanoic acid and this is alcohol. So alcohol when react with the ethanoic acid form this compound, this is ester. Okay, so this is CH3, this is C double bond O from this side, and this O to form this compound, and this is form ester. Complete the table with the reagents and condition required for each of the reactions shown. Reaction 2, E and J, E to J. E to J, bromine head is replaced by the OH group. So this is nucleophilic substitution, and reagent is sodium hydroxide aqueous. And C to G plus O, hot concentrated KMnO4. This is C. This is C. Over here double bond, hot concentrated KMnO4 break this double bond and form these two products. Okay, and this is C and G. This is G and this compound, hot concentrated J and G concentrated sulfuric acid. So this is the catalyst because it is carboxylic acid, it is alcohol. When they react with each other, this is condensation reaction, and condensation takes place in the presence of concentrated sulfuric acid. This is all about of this paper. Hopefully you understand this paper. If you like this video, please subscribe.